Yes, good morning Kenyans. My name is Agre Buchunju. Welcome back to our math lesson. This is our third day. We are still on Form 4 Mathematics and we are handling longitudes and latitude. And today we are going to look at a subtopic known as finding distance along small circle. I've got two diagrams here. My first diagram is there. My second diagram is here, which I've extracted from the main diagram. Now, for us to find distance along a small circle, we must show or we must know the relationship between the relation between the radius of the Earth and the radius of the small circle. Now, if you look at this particular diagram, this radius and this radius with small letter, they are parallel. Now, this one is a diagonal. It means that this angle here and this angle here are the same. So if this is theta, this is also a theta. Number two, we can extract this particular diagram and make it simpler. What I'm showing you is this. This R is capital R, which is the radius of the Earth, which is the same as this one. And now this one is the radius of the small circle. And I've said, because of this one being diagonal and these lines are parallel, it means this angle here and this angle are the same. Now, we want to show the relationship between this one and this one. We are going to use a cosine, the cosine. Now, this one is a right angle triangle. We are going to say cos theta, which is the theta is here, is equal to adjacent, which is small r, all over hypotenuse, which is a capital R. So we are going to make R to be the subject of the formula. So we are going to multiply by capital R, multiply by capital R. So we are going to have our small r as is equal to R cos theta. So this one is the relationship between small r and capital R, because we are always given the radius of the Earth, but we are never given the radius of the small circle. But once you have got the radius of the small circle and you have got the cos theta, now in this case, theta here stands for a latitude. In other words, it is just like saying r is equal to r cos latitude. So if we want to find distance along a small circle in a kilometer, number one, we are going to say the first one, it will be alpha. Now our alpha is the angle difference all over 360 multiplied by 2 pi r. Pi r. So r is the small r. But at least we know r is equal to r cos theta. So in other words, in kilometer, we shall be saying alpha all over 360 2 pi r cos theta. That one is in kilometer. And if we want to find a distance along a small circle in nautical mile, we shall say alpha multiplied by 60 and then cos theta. And I've said that our theta is our latitude. So we are going to apply this one in our first example.